So we're going to take on a kind of big project now, and what we're going to try to do is we're going to try to use our knowledge and everything that we've learned so far to make a blackjack game that we can play against other players or against the computer. So let's start off. The first thing that we're going to need to do is we're going to need to create our deck. And so maybe the best way to do that, rather than kind of putting in all these values randomly or manually, is to put them in using a function and a loop, so that we can just kind of create the deck using a function. So let's start off. What we're going to do is we're going to create a function. So we're going to use the def keyword, and then we're going to create a function, and we're going to call this function create deck, and because that's what it's going to do, we're going to open and close parentheses. We're going to have no input for now, and all that it's going to do is at the very end, it's going to return our deck to us. So we're going to make a full kind of poker deck using this function, and we're going to use loops and stuff to kind of simplify things. Yeah, so that's what we're going to do. So we're going to start off with our deck, and it's going to be an empty list, and part by part we're just going to fill it. So what we're going to do is we're just going to use a couple of for loops to do that. So the first thing that we're going to need to do is we're going to need to add all the integers, and then after that we're going to need to add all of the face cards and stuff. So the ace, but the jack, king, queen, and yeah, ace, jack, king, queen. So that's the other cards that we're going to need to add. So yeah, let's start off, and we're going to need to add 4 of each of them because there are going to be 4 different suits, but we don't really care about the suits, so we're just going to add each card 4 times because, well, if we're playing blackjack, we don't really care about the suits. If this were poker, it'd be different, but we're just going to use normal kind of cards, and we're not going to really care about the suits. So we're just going to add each value 4 times. So since we need to add each value 4 times, that's probably indicating to us that we need to loop 4 times. So what we're going to do is we're going to make a loop that goes 4 times. So for I in range 4. So what we're doing is we're just taking a dummy variable called I, and we're just making it loop 4 times. And so what we want to do is, well, first of all, to our deck, we want to add all the numbers between between 1 and 10, but not including, or actually up to and including 10. So we're going to take all the numbers. Actually, we don't want 1 because we've got our ace, so we want 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we're going to do is we're going to take another for loop, and we're going to go for, and our temporary variable now is going to be called card, and our card is going to be in range from 2 up to, but not including, 11. So what we're doing is our card is going to take on the values 2 through 10 4 times, and what we can do is we can just add each of these values to our deck. So every time we have one of these values, we're just kind of put it onto our deck, and we're going through it 4 times because there. So we can just add this as a comment. There are 4 different suits like that, and here adding the numbers 2 through 10. So this is what we're doing here. So that we're doing it 4 times because there are 4 different suits, and we're adding the numbers 2 through 10 here. So what we can do is we can go into our deck, and to our deck we can append the card. So yeah, this is how we're going to get all our numbers in there. Now we just have to get in our face values. So what we can do is we can make a little list called face values, and we're going to put in all our face values here. And so what we can do is we can just go through our face values list, and we can add each value to the deck. So since our face values aren't that many, there are only 4 cards there, we can actually write them out manually, and we don't have to come up with an extremely smart way to create all these face value symbols and stuff. We can just write 4 cards. We can write out 4 letters, and then we're going to loop over it 4 times, and we're going to add that all to our deck. So our face values is going to be a list, and it's going to contain an ace, or a capital A for an ace. It's going to contain a jack. It's going to contain the queen, or a queen, because there are 4. And it's going to contain a king, so capital K for king. And so this is what our face values are. And so to get those into our deck, we also need to just loop over these. Now we want to make sure that when we go on a new line here, that we're not inside of this for loop anymore, because we only want to add 4 of them, rather than 4 times, well, 2 to 8, so 4 times 9. So rather than adding these 36 times, we want to make sure we're out of the second for loop, so that we only go through it 4 times. So what we're going to do now here is for card, and we're just going to use the same temporary variable. So we're going to use card to represent the numbers 2 through 10, and we're also going to use card to represent these face values, because it's just a good name for the variable. So for card in our face values, so we're going to go through this, and if we have a colon here, so if we remember what this does is our temporary variable, which in this case is card, goes through the face values element by element. So it's going to take on A first, then J, then Q, and then K. And so that's what the for in does into a list. Our temporary variable is going to take on each of these values individually, like this. And what we want to do is just to our deck, we want to append the face values, like this. And so we're adding our card numbers here, we're adding the face values, and we're doing that 4 times. So this actually kind of completes our deck already. Maybe something that we want to do, just so that everything kind of matches up nicely, is we can turn these integers into strings. And that's just because we have strings here, or we have characters here. So we want to kind of maybe keep them all in the same type. So we don't have to do this, but it may be nice just to have everything in the same type. So we're going to convert all of these to strings too. So we're going to have all the numbers 2 through 10, and they're going to be represented as words here, or as strings or characters. And we're going to have A, J, Q, and K, and we're going to have each of these 4 times. And that's what we're going to return from the create deck. So to see our deck, what we can do is we'll make a deck variable that we're going to save it in, and our deck is going to be equal to, and we're going to use the create deck function, and we're just going to open and close. And so what our deck is going to be equal to is it's going to be equal to whatever is returned from here. So what in this case the deck is returned to us, and now this name here doesn't have to be equal to this one here, so I could call this the card deck, for example. It doesn't really make a difference. I just use deck because it's a good representative name, because it describes nicely what we have, but card deck works just as well. So these names here don't have to be equal. I just did that for convenience. And maybe just to make sure it works, we can actually print out the card deck that we've created. So if we run our code, let's see what we get. So, well, what we see here is we get 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we get a list containing A, J, Q, and K. And then we get another list. So we may have probably done some mistake. And that mistake was that we appended the whole list face values. So what we actually wanted to do here is we just wanted to append the card. So that was a little mistake that we did in our code here. Thankfully, we printed it. So we were able to see all of that. And so this looks fishy. So if we run it now we see we get 2, 3, 4, 5, 6, 7, 8, 9, 10, AJ, QK, and then 2, 3, 4, 5, 6, 7, 8, 9, 10 again, and AJ, QK, and so on. So we get each of those 4 times. So printing can also kind of help us detect some of these smaller errors so that we don't run into anything big. So it's always a good idea to sometimes print. It can also be used nicely for error checking. Yeah. So, but we've kind of done what we wanted to do now. We've created a deck, and yeah, we're not really taking care of the suits, but we've purposely decided to not care about the suits. So we could have added the suits if we wanted to by adding a little bit of information here, but we decided not to do that because we don't need that. We only care about the value that each of these cards carry. So yeah, Now we've created this little function here, how to create a deck. But what we can see, for example, is that everything is ordered. So maybe we want to shuffle everything up. Now, if only there was a way to do that. Well, fortunately, there is. We can use the random library, and we can use the shuffle function in there. So since we don't need the whole random library, let's just go and take from random. We want to import, and we want to import the shuffle function. So if we remember what the shuffle function does, is it takes a list and it just mixes it up, and it mixes up all the elements. And so that's what our shuffle function does. So from random, we're going to take the shuffle function, and then what we're going to do is down here, we're just going to shuffle the card deck. So that's really all we're going to do. And we don't need to save this anywhere or something. The shuffle just kind of does that automatically. So if we shuffle the card deck, then it's all being saved into the card deck automatically. And we also don't need to do the random dot because we didn't do import random, but from random we imported shuffle, so we don't actually need to go into random. We can take this away and directly use shuffle. And so we see that if we run our code now, well, now our whole deck is shuffled. So we can now maybe nicely use this just element by element, and since we have a shuffle deck, and just kind of use those to give out the cards. So if we run it again, we see that we get a different kind of shuffle deck. If we run it again, we get a different kind of shuffle deck. So what we've done is we've created a nice little function that makes a deck for us, and then we've just really nicely shuffled it. We can also put this shuffle inside here, so that's really our preference if we want an unshuffled deck when it comes out, or if we want to shuffle our deck, or if we want to shuffle our deck before. So we could also do, for example, is we can go in here and do shuffle deck. So since we imported this shuffle function, we can use it anywhere we like, and we can use it inside of here too. And here we have to shuffle the deck because that's what's contained inside here. So what we can do is we can actually take this out, so we can comment this out, and if we run this, we see that we immediately get back a shuffled deck. Yeah, so that's really cool. We've used kind of the for loops. We've used the function definition, some variables with lists, and we've used the random library, and we were able to do that, and we were able to use that to make a kind of cool function that, with little repetition, creates our whole deck for us. What we've also seen is we've printed the card deck, so we were able to detect an error that we had before. That was from here. So what we did actually is we printed out, or we added the list of face values rather than the individual elements, because we accidentally put the face values instead of the card here. So we also did a little bit of preemptive error checking or preemptive debugging. So that's what the print also allowed us to see. But yeah, the print also just allows us to see that everything works now. Yeah, so this is the first kind of checkpoint or milestone that we've reached in our BlackJack game. And then we'll just kind of continue on in the next video. Now let's continue on with the BlackJack game that we started to create. So if we just have a short recap, what we did last time is we created a create deck function that starts off with an empty deck, and it gives us back a completely shuffled deck. And how does it do that? Well, we define some face values, so we define the 4 face values in a list, and then we loop through 4 times because we have 4 different suits, and for each loop we've added all the numbers to our deck, and we've also added all the face values, and we do that 4 times, and we kind of discarded the suits. We just added in the actual cards, but we didn't really care about what suit they were because that's not really important to us. At the very end, we called the shuffle function that's contained in the random library, and we just shuffled the deck, and then we returned the deck. And so this function creates for us a completely shuffled deck that's full. And we just save that in the card deck. So if you run this one more time, we just get back this really nicely shuffled deck. We can't really identify the suits because we didn't put in any identification here for the suits, but that's okay. We don't really need the suits anyway. So yeah. So now we've learned how to create this deck, and we have that in our arsenal. So what we're going to do next is we're going to create a player class, so a player that's going to be able to play this game. And since we maybe want to create more players, we're gonna make it a class so that we can keep repeating it and so on and so forth. And it's gonna have lots of functions and properties and whatnot. So let's just start off. We're gonna create this class player, so we're gonna use the keyword class. And now we're gonna put in the name. So the class name is gonna be player, and we have our colon here to indicate that we're gonna start the class definition. And the basic thing that we do when we define classes is we first have to define an initializer. So we start off with the def, and then we go underscore underscore init, underscore underscore, just like this, open and close parentheses. So this is kind of our initializer definition with our colon here. We're going to be adding the input variables in here later. Let's just start off with the self because we're inside of the class, but everything else let's just add later after we really define what kind of features we want to have. So what kind of attributes do we want the player to have? Well, the player needs to have a hand. So we're going to go self.hand, and this is going to be one of those attributes that we need to have. And we'll also think about the data types in a second. So first we want a hand. The player also needs to have a score. So it's going to have a self.score. And so this is going to be the score of their hand. And that's also going to have the value. And well, that's really all we need right now. We can add some money. So self.money, and so this is going to be their starting money that they're going to play, whether they're starting capital or whatever you'd like to call it. So these are kind of the three basic things that we need. We need a hand, we need a score, and we need money. So these are going to be the three basic attributes that our player are going to have, and we can expand on this later too. But yeah, let's just start off with this. So we'll start off, and we're going to put in the input variables now. So our hand is going to be our hand, our score is going to be score, and our money is going to be money. And maybe let's just not capitalize this to have everything consistent so we don't get confused. And so our self.hand is going to be equal to the hand that we put in, or that we give it. Our score is going to be equal to, well, actually we don't need to put in a score yet here. So we can set this to 0 first because our score is going to be based on our hand, and we're going to make a function inside of the player that's going to calculate our score for us. And our starting money is just going to be equal to the money that we put in here. So we actually took out the score from the initializer and just set it as a constant value. Because our score is going to get kind of recomputed every time we give it, every time we update the hand and stuff. And so just to kind of allow basic values, or to allow initialization without putting anything inside, we're also going to give these standard values. So in case nothing's put in, we're going to say the hand is going to be equal to an empty list, and the money is just going to be equal to 100. So this is if the hand isn't defined or if the money isn't defined, these are the standard values that they're going to take it on. So these are the defaults. The reason that we're going to be using a list is because then we can nicely store the elements, and we can go through them one by one and just compute the score of each of them. So we can have kind of a mapping, and we can store each of the elements in this list, and then we can go through each of the elements one by one, and for each element we can calculate a score, and we can add that on to our total score. So this is the initializer function. Now, maybe something else that'd be really important for us, or definitely also for the player, would be to be able to see their hand and their score every round or something, or every time it's updated. So what we're going to do is we're going to overwrite the print function for the player so that we can just continuously print player, and every time we print player, we'll see the hand, and we'll also see the score. So what we're going to do is we're going to define, and then we're going to overwrite the underscore underscore str method. So we're going to overwrite the str. So we go into underscore underscore str, underscore underscore. And then we open and close parentheses. Inside here, we again have to put in the self. And then we're just going to put our colon here. So if you don't really remember what this does is it allows us to call print on player. And we're just going to define on the next line here what's going to happen, or what it's going to return if we call print on player. So what we want to return is we want to return the hand as well as the score. So maybe before we return something, let's make a variable, a temporary variable, and we'll call this current hand. And this is going to be equal to an empty string right now. And yeah, so what we're going to try to do is, rather than returning our hand as a list, we're going to try to make it a little bit prettier, and we're going to actually return all of the elements in our hand. So we're going to return each element in the list, so that we don't see a list like this when it comes up, but that we actually just see the hand that we have. So to do that, to make it a little bit more aesthetically pleasing, we're going to make a for loop through our hand. So for card, that's going to be the name of our temporary variable. So for card, in our self.hand, we're going to do the following. So what we're doing here is we created a variable called current hand, which is empty right now. And for example, if our self.hand looks like this, so we've got an ace and maybe a 10 or something, what we want our current hand to look like is going to be something like this. So what we want the current hand to be is something like A and 10. That's all we want. So just that we get rid of this list stuff here, and that we just kind of print out what we have. So what we're going to do is, since we're looping through the hand element by element, and since we're going to make sure that the elements in our hand are going to be strings, what we can do is we can take our current hand, and to it we can just add the card. Now, if we're not sure if the card is going to be an integer or a string, we can also just put the str around it, just in case. So this is going to kind of save us from running into some potential problems, in case maybe in our deck we put in integers instead of strings or something like that. So worst case, we're going to convert it to a string here, and we're going to add that to our current hand. And also what we're going to add to the current hand is going to be a kind of space like this. So this is just going to give us this formatting that we want. We're going to get our card here, then we're going to put it in space, and then we're going to get this card here, and then actually we're going to get a space after that. But that's okay, because we can use that in a second. And so what we maybe just create our final value that we want to return. So the final status is what we're going to call this variable, and so this is going to be the final status that we're going to return, and it's going to have the hand of the player, and it's also going to have the player's score. So the final status is going to be equal to, and we're going to have our current hand. So what we're doing is we've created this final status variable. Inside of it, first we're going to see the hand, and then what else we're going to add to it is plus, and then we're going to add score like this, and just put a colon here and a space for some formatting, and then we're also going to add the string version of our self.score. So that's all we're doing here. Let me just make this a little bit bigger so that we can see. Oh, good thing I did that, because there's a typo here. So what does our final status look like? Our final status takes our current hand, which looks something like this, and it adds to it score. So it's going to look like, for example, the current hand is going to be A and 10, and to this, and then there's another space here, to this it's going to add score, and then a colon, and then it's going to add another space, and in this case the score is going to be 21. So this is what the final status is going to look like. And in case we have more values here, for example, let's say we have a 2, then our score is going to be 23. So that's how it's going to look like for more values. And then if we put in more values here, so like a 4 like that, then this will be equal to 27. So just kind of like that. Or actually, well, if we reconvert our ace, this will be equal to 16. So ideally, 17. Ideally, that's what we're going to get. So since the ace can be either a 1 or an 11, we're going to use that best to our advantage. So if we have a hand like this, this is where we're going to get to. And all we want to do is we want to return the final status like this. So that's just going to print out this. And so what that allows us to do is if we call print on player, what we're going to see is we're going to see this here without this pound. This is just for comments. But we're going to see this if we call the print on player. And so this is just a nice handy method that easily lets us see where we're at right now, how are things looking, and we can print that out to the player so that they also know where they're at. So yeah, we've initialized our player. We've also been able to print the current status. What else do we need? Well, we actually need the get score function. So we need to be able to get our score. So we're going to do def, and then we'll call it, well, actually let's call it a set score, because that really is what it's doing. It's recalculating the score. And so how are we going to do that? So what we're doing here is we're defining a method or a function, or well, it's a method because it's inside of a class called set score. And every time we call this, it's going to recalculate the score of our current hand. So how is it going to do that? Well, we are going to have to somehow go through our hand, and each value we're going to have to we're going to have to convert into the appropriate score. So how could we do that? Well, if we have numbers, it's quite easy. All we have to do is convert the string to an integer, so that's no problem. But if we have a face value, for example, like an A, we need to somehow convert that to the appropriate score. So how are we going to do that? Well, something that we need to do is we're going to need to loop over all of our list, and yeah, we're going to need to create this mapping. So a good approach, for example, and of course there are many different approaches, would be to create a dictionary. So yeah, let's just create a dictionary. And since we only need to create a dictionary for the face cards, because we can convert our integer or our numbers here to integers, we only need to create a dictionary for the face cards. So we can call it face cards dict. That's going to be our face cards dictionary. And what we're going to have inside, so it's going to be equal to, and we're going to open and close parentheses. What we're going to have inside here is we're going to have the face card values, and we're going to have the core, or the face card keys rather, so how they look like, and we're going to have their corresponding score. So for example, for ace, we're going to have 11. For the jack, we're going to have a 10. Also for the queen, we're going to have a 10. And for the king, we're going to have a 10. So this is one of those ways that we can do that mapping. And now you may also see already that maybe we don't need this because the jack, the queen, and the king all have the same value. So all we have to do is, if we encounter one of these, we just have to convert it into a 10. And our ace is actually a 1 or 11, and we're not really taking care of that. So let's just, but this is kind of the first thing that we thought of. So let's just roll with this for right now. But we can still change that later to make it a little bit more efficient, efficient or working better, or maybe just a different version. So what are we going to do to calculate our score? Well, what we need to do is we need to loop through our self.hand. So for each card in self.hand, what we're going to need to do is we're going to need to convert the card into a score, and we're going to need to add that score to our self.score. So how would we do that? Well, first maybe let's check if our card is an integer. So if we have a value 2 through 10. So and how are we going to check now if our card is an integer? Well, so our card is going to look like this. It's going to be, maybe if we have a 10, it's going to look like this. So what we're going to need to do is somehow we're going to need to try to convert this to an integer. And then if it is an integer, then we can add it. So how are we going to do that? Well, what we can do is we can try to cast this to an integer. So if the integer version of the card, so we want a lowercase I here for integer, if the integer version of the card, and then maybe what we can do is we can check if it's in range from 2 to 11. So if we convert this card to an integer, and it's going to be in range of 2 to 11, and now we may run into some problems here later, but this is just kind of, we'll fix these all later. So we're probably going to get some errors when we run into the aces and the jacks and the queens and the kings and stuff. But to start off with, maybe this is just what we're going to go with. Let's write this down, and then let's try to find a better fix for it. So if the integer version of our card is in range from 2 to 10, what we can do is we can take our self.score, and to it we can just add the integer version of our card, no problem. So all that we're doing right now is if the integer version of our card is between 2 and 10, or is in the range from 2 to 10, up to and including 10, so less than 11, we're just going to add the integer value of that card to our score. If it isn't, else, then what we may want to do, or what we can do is an elif, so else if, and then if our card is in our face cards dictionary, then what we can do is we can add the corresponding value to our score. So self.score plus equals, and then we go into our face cards dictionary, and here we access the key that we're getting, and the key in this case is the card. So for example, if we have an ace here, what we're going to do is we're going to see is A in our face cards dictionary. It's right here. And then what we're going to do is we're going to access this A in the face cards dictionary, and this is going to give us the value, which is going to be 11. And if it is 11, then we're going to add that to our score. And so it'll work the same for jack, queen, and king. And so this is kind of the simple way of going about it. So this is just going to give us our score in the end. We don't really need to return anything or such, because we're just kind of changing our score internally. An issue that we are definitely going to run into is going to be that our int version of the card, so if we check for an ace, for example, it's going to complain. So for example, we can just do a little test here using our literal interpreter. So if we say, for example, x is equal to a, and if we just rewrite this if statement here, so if int of x in range from 2 to 11, so let's make this a little bit bigger, then what we're going to do, let's just print out int of x. So if this is the case, then we're going to print out int of x. Now if we run this, we see, well, oh, we're already getting an error, so our a is not going to be able to get converted into an integer, so we're definitely going to need to fix that somehow. Maybe the quick fix that we can do right now is we can just add all of these values to the dictionary, and we're going to get rid of this dictionary later. most probably because it's not that nice. It's kind of messy. So maybe let's just continue this dictionary on the new line, which we can do because we added a comma here. So our 2 is just going to give us a value of 2, and our 3 is going to give us a value of 3. Our 4 is going to give us a value of 4. Our 5 is going to give us a value of 5. 6 is going to give us a value of 6. And let's just continue on a new line so that we don't kind of go off here. 7 is going to be 7. 8 is going to be 8. 9 is going to be 9. And our 10 is going to be 10. So what we've done now is we've created a dictionary for pretty much all of the cards. We haven't taken care of the ace being a 1 or 11, but we've taken care of everything else. So we can actually already just take this away. And well, we actually don't need this start statement either here. So what we can do here is if card is in face cards.dictionary, well, it is. So even this we can actually take away. And all we're left with is, with our dictionary right now, all we're left with is that our self.score needs to be added to, or our current score is going to be added to the self.score. So we're going to go through it one by one, and we're going to check our corresponding score, and we're just going to need to add that to the score. So now we need to somehow keep track of these aces. So we need to be able to keep track of when we have an ace, and if we go over, then we want to be able to change the value of the ace. So what we can do, maybe a neat little solution, is that we can make an ace counter. So we can have our ace counter, and the ace counter is going to start at 0, and it's just going to count how many times we have aces. And then we're going to check in the end if our score is bigger than 21. And if it is, then we're going to change the value of our ace. So what we can do here, for example, is after we add it to our score, so after we've added the ace to our score, what we can check, for example, is if our self.score is greater than 21, so if we kind of bust, and then we can make another check, and our ace counter is not equal to 0, what we can do is we can kind of subtract 10 from here. So what are we doing in essence? Well, let's just finish this. Self.score, and then from here we're gonna subtract 10. And let's go through this and understand what we're doing. So we've created a little dictionary that gives us the values of our cards here. We've defined all the face values. We've also defined all the number values, and we just kind of go through each card in our hand, and we add the corresponding score that we see here in the dictionary to our score. And then what happens is we also have an ace counter. So if our score is greater than 21 and our ace counter is not equal to 0, so if we bust, if we have more than 21, but we have an ace, we can actually change the value of our ace from an 11 to a 1. So we can subtract 10 off of our score. And so all we have to do now is just kind of keep track when we have an ace. So we can make another if statement, and preferably before, in case our last card is an ace and then we bust. So if our card is equal to an A, so if our card is an ace, then our ace counter, what are we going to do to it? Well, we've encountered an ace, so we need to increase the ace counter by 1. So to it, we're going to add 1, so we're going to increment it by 1. And so that's what we're doing. If our score is bigger than 21 and ace counter is not equal to 0, then we take 10 off our score, but only if our ace counter is not equal to 0. So how do we kind of compensate for overcounting the aces? So if we, for example, get an ace, and and then we get, let's say we get a 7, and then we get another 7, which gives us 25 in our calculation. But then we see that our self.score is greater than 25, so we take 10 off, so we have 15. And then if we draw another 7, then our ace counter is still not going to be equal to 0, and our score is going to be greater than 21 again. So 15 plus 7 is going to be 22, so we're going to take another 10 off. But that's not good because we only have one ace. So what we're going to need to do also is we're going to need to take 1 off of our ace counter so that we don't reuse the aces that we have to kind of just give us whatever score we like. So this is one of the versions that we could maybe use to implement to check for aces. Of course, there are many others. This dictionary solution is also just something that's a little bit straightforward, that's going to be easier to understand. But we can also change that, and we can do it a lot more intricate. But yeah, I mean, what's really nice about this is that we just kind of see the example of a dictionary in action. So we have a corresponding score assigned to each card, and we go through these cards here in our hand, and we add each of the corresponding scores to our score, and then we check for the special condition if ace is 1. And so since we can only define one value in the dictionary, in case we do encounter an ace and we bust because of the ace because we added 11, we're going to kind of compensate for that, and we're going to take 10 off. But then we're also going to change our ace counter. And so this is how we're going to be able to set our score. So we're going to be using this a lot because we're going to need to use this every time we get a new hand, or every time we get a new card even. We're going to need to recalculate our score. So what we can do already up here is we can change our self.score, and we can change that to be equal to our self.setScore, and then open and close parentheses. So why can we do that? Well, we've already defined our hand, so our hand is the first thing that we put in, and our score here is what we get, is our way of calculating the score. So all we need to do now is we just, well, since we're actually changing the self.score internally, we really don't have to do a lot. Something that we should be careful about, though, is if we start off with nothing in our hand, then our self.score is going to be, well, a little bit weird because it's not defined yet. So we haven't set an initial value here, and so it won't be able to. We'll just pretty much start off with a random value. That's what we're going to get. So since we didn't set an initial value for our score, and we're immediately going into calculating our score, that may be not so good. So maybe we can just start off with 0 here, and on the next line we can calculate our self.score new to be equal to self.setScore. So the reason we're doing this is first we set our score to be equal to 0, and now we can kind of reset our score, because now when we access our self.score and add values and stuff to it, this actually has a predefined number. So now this is set to 0, like we have here. And if we didn't have this extra line here, then we wouldn't really know what our score is initially. So yeah, that may not be so nice. I mean, something else that we could do technically is we could move this, and we can move this here, so we can set our self.score to 0 initially here. And that kind of takes care of that problem, because so something that we forgot too is we need to put the self in our parentheses here. So that's very important, or else we're going to run into issues because we're inside of a class, so we need to be able to reference self. But what we're doing here now, so now if we set our score and we go into the set score, the first thing that we do is we set our initial score to 0 because we haven't calculated our score yet. And then we're going to go through all of our cards, and we're going to add the appropriate amount to our cards. So each time we kind of reset the score and calculate the score new, which works pretty well, especially if we recalculate the score each time. So if we don't reset our score in the beginning and we just continue adding, then if we set our score twice in a round or something and we haven't reset our score, we're just going to recount all the cards we had before. So what do I mean? If we call our set score once, and we have, for example, a 3 and a 4, like this, and if we then draw, let's say we draw a 10, so then we have a 3, a 4, and a 10, and if we call our set score the first time, we get 7. So let's just write this out. So if we call our set score the first time, we get 7, and then if we call it again, we get 7 plus 17, and so we technically get a score of 24, but our score is actually 17. So we need to make sure that we don't just add on to the score previously, so every time we recalculate the whole score, we're just going to reset it in the beginning. And so that's to make sure that we don't add on to our previous calculation of our score. Of course, there are different ways to do this. You don't have to recalculate the score every time. You could just start, you could, for example, put in here an index and start at that index to calculate the score, and then you wouldn't have to reset it. This is just one of the ways that you can do it. There are different ways. This was just very user-friendly, and it really lets us see the use of the dictionary too, so that we're kind of seeing the use of lists and dictionaries a lot, and hopefully we're getting a little bit more acquainted with them and being able to see a little bit better when we can apply them, and when we can't, and when they're nice. When should we apply them? What are they good for? So let's just create a test instance of our player, and then we can continue moving on to adding more features to a player in the next tutorial. So let's just create a player first though. So what we're going to do is we're going to create a player one, and this is going to be equal to our player, and we're just going to put this in manually right now. We're not going to access their deck yet or anything. So let's just give them the cards 1, or well, there is no 1. Let's give them the cards 3 and 7 like this. So this is going to be their hand, and we're actually not going to put in a money, so we're going to see the default value of money being set, and then let's print our player, and let's see what we get, and hopefully we get the 3 and the 7 and the 10 for our score. So let's see. Printing our player. What did we do wrong here? We returned the final status. Where we have to print our player 1. So we want to print player 1. We don't want to print the general player class, but we want to print our player 1. So if we run this again, we see we get 3 and a 7, and our score is equal to none. So why is our score equal to none? Let's see. Maybe after here we can print our self.score. And let's see what we get here. So if we run this again now, we see, well, our self.score is set equal to none first. And then, so that's why we're getting none here. So maybe if we try to also just print out our self.score here to see what happens here. So print out our self.score. Maybe we did something wrong here. So here we see we get a 0. So we're going in here. We're setting our self.score. So our self.score here is equal to 0. We should probably also return is what we should do. We need to return out our self.score. So we actually need to give something back at the very end. So that's why we can set this here. So since we're setting our self.score to be equal to the whatever we get in here in the set score, we actually need to return our self.score. So we need to kind of pass this back, and this value that we pass back is going to be what this is going to be equal to. So if we run this now, we see, well, we get the 0 when we print our self.score here, we get the 10 when we set it here, and now we get what we're looking for. We're getting the 3 and the 7, and this gives us a score of 10. Maybe if we add one more value, let's say a 5, and we run it again, so now we get the score of 15. So everything that we're doing here is just kind of hard-coded, but this is just for testing. We see that our player runs, the set score runs, at least for now. Maybe we want to change it later too. but basically everything runs. We've seen also a little bit of debugging, so this print statement is extremely useful for debugging, and it can quickly tell us where an error is. So in this case, the problem was that we didn't return anything, and since we're just having a local variable here, so we're not, if we set our self.score here, we're just setting it locally, and we're not, well, not really, but we're not returning anything. So if we're not returning anything, and we're setting our self.score to be equal to whatever we return from here, and if we're not returning anything, then our self.score is going to be equal to none, no matter what we did to it inside of here. The last thing that it's going to be equal to is whatever was returned out of here. And since we didn't return anything, this value kind of got reset to none. So yeah, we can see how useful these print statements are to debug. So that's kind of a really great quick fix method, and it lets you get a nice kind of overview of your code. But yeah, so we've done the simple implementation here. Our player is nowhere near complete, so we're gonna move on, and in the next tutorial we're gonna expand our player's functions a little bit more and be able and have them be able to do more things like draw cards and such. Let's move on with our BlackJack example using our player. And in the last section, what we did is we created an initializer. We've created a print method for our player, and we've also defined the set score method. And so maybe two more things that we want to add is we want to be able to hit a card. So we want to be able to take a new card, and we want to be able to play a new game. So we kind of want to reset. Now, of course, there are more things that we can do later too. For example, splitting and all that stuff. But let's just keep it simple right now, and let's just stick with the basics. So the next thing that we want to add is we want to be able to hit a card. So we're gonna, and if you don't know what hit means just take a new card. So that's what we're gonna be able, what we want to do. So we're gonna define a new method, and we're gonna call this method hit, and we're gonna open and close parentheses. Inside here, we're going to need to put the self, like always. And what we're also going to have here is we're just going to have the card. So what we're going to do is if we hit, we're going to pass a card with the hit, and then we have our colon here. And all that we're going to do in this hit function is to our self.hand, we're just going to append our card. So what are we going to do? We're going to take our self.hand, and to it, we're going to append, and all we want to do is just append the card. That's all our hit function is going to do. Well, it actually needs to do one more thing. It needs to set the score again. So what we need to do is we can change our self.score, and we can make that equal to set score. So after we added this card, all we're doing is we're just going to recalculate our score. And it needs to be the self.setScore, because the set score is part of the class, so it's one of the class methods. So we actually need to access the self part here. Since our card is part of the input here from the method, we don't need to access the self because the card is not part of the player. So it's not a property of the player. It's just something that's passed in the function. But this set score method is actually part of our player, so we've defined it here. And so to access it, we also need the self in front of here. But yeah, so this is kind of all that we need to do when we hit a card is we just need to see, well, we need to add the card to our hand, and then all we need to do is we need to reset our score. So this is all that we're doing with the hit. So maybe if we run this, or maybe if we just user player1 dot hit, inside here we're going to put the card that we're going to hit. So what we're going to put inside is we're going to put inside, let's put inside a king, and then let's print out player 1 again. So if we print out player 1, remember we access this overwritten print function here, and we print out our current hand plus our score, and we show that up. So yeah, let's just run that and let's see what we get. Let's make sure everything works. So this is the output that we're getting before. Maybe we can remove some of the print statements like this, and let's just rerun our code now. So first we see our shuffled deck. We're not really dealing with that right now, so we're not really doing anything with our deck, but we still see it. It's still being shuffled every time, and every time it's different that we see here. And so our player starts with the 3, the 7, and the 5, and their score is 15. And now the player hits the card, and their score is 25. So we've busted technically, but we haven't really taken care of that either. We just kind of see our score. So this is all that the hit method does, and we see it's working nicely now. We're adding a new card here, and our score is also being recalculated. So maybe let's also hit an ace, player.1, and then here we're going to hit an ace. So we're hitting 2 cards, we're hitting a king and an ace. Let's just make sure that we get the extra 1 here rather than the 10, rather than the 11 that we want. So yeah, we see we get the 26 here. That's great, that's exactly what we need. If we take this king away, for example, so if we comment out this player hitting a king and just put in an ace, and if we run it again now, we see that we get 16, which is great too. So we get the 3, the 7, which makes 10, plus the 5, which makes 15. And now if we added 11 to it, that would give us 26. But since 26 is greater than 21, our ace is going to count as a 1. And so what we're going to do is we're just going to subtract 10, and we get the 16 here. Now if we hit another ace, for example, player 1.hit, and we get another ace like this, we see that our scores increase to 17. So we're not really running into any issues here. So that's great. And we're also not dealing with this overcounting issue. So we've kind of taken care of everything, or at least that's how it looks like now. So that's really great. Everything seems to be working here. We didn't run into an error, so our hit seems to be doing the job nicely. So the last thing that we want to do maybe is we want to create kind of a reset function. So we want to be able to, once we've played our game and stuff, we want to be able to reset our hand and our score without having to destroy the player and then recreate it or something like that, or just create a new player. So we don't want to need to change players every time. We want to be able to reset our score. So we're going to create a method called def, not def, we're going to define a method, and we're going to call this method play. And what play is going to do is it's going to take in a new hand. And we need to put the self in here too. We can't forget the self. So we always want to refer to the self because this is a method that belongs to our player. So we need to put the self in there. And what our play is going to do is we're going to get a new hand. And what's going to happen is our player hand, our self.hand is going to be equal to the new hand. And our self.score is going to be equal to, well, what is it going to be equal to? We're going to need to reset our score, so it's going to be equal to our self.setScore. So we're just resetting our score with this new hand. And let's try that out too. Let's say player1.play, and now we give player 1 the cards. Let's just give them an ace and a king, so a nice winning hand. And let's print out player 1 again to make sure everything still works, and we've reset our hand and we've got the working score and everything. So if we run this, we see we have the 3, 7, 5 here with a score of 15 from the beginning. Then we hit 2 aces and we get 17, and then we play, so that resets our hand and it gives us an ace and a king because that's what we put in here, and our score is now 21. So cool. We've created this, or we've implemented this nice hit method. We've implemented this nice play method. Yeah, maybe one more thing that we want to be able to do is we want to be able to bet money, or we want to be able to set our money. So what are we going to do? Well, we are going to need to be able to create a bet method. And so we should think about first, well, what do we want our bet method to do? So what we're going to do is we're going to bet some money in the beginning, and if we win, then what we're going to do is we're going to double that money, or whatever it is that we do. If we get a blackjack, we're going to do it by 1.5 times, so we're going to get 250% of our original value. But what we're going to do is we're going to need to kind of take care of this betting. So we can kind of change this around later, but let's just start off with with two simple methods, and we're going to remove these later and make a more general bet method that takes care of everything. But then we also need to put it in all of here. But first, let's just start off easy with pay. So we're going to define a pay. So this is going to be kind of, they put out the money, and we're going to reference self here because we're in our class, and we're going to put in amount here. And all that it's going to do is it's going to take our self.money, and it's going to decrease it by the amount we paid. So that's all our pay is going to do. And the next thing that we're going to do is we're going to create a win method. So we're going to create def, we're going to win, and we need to reference self here, and we're going to put in the amount that we won. And what we're going to do is we're going to take our self.money, and to it we're going to add the amount that we won. So all we made is two really simple methods, one that pays. So this is kind of when you start your round and you put in your bet, and if you win, then you get back the double amount. And again, we're probably going to change this later to be something more general so that the bet actually gets taken care of internally. But right now this seems to do the job. But when we get to a more kind of complete and complex game, then we'll notice that we probably want to change this to make handling everything easier, or else we're going to need to save the bet somewhere else. But it'd probably be better if each player remembers how much they bet, and then if they win or if they lose, the bet either gets doubled and they get it back as their money, or they lose their bet. So later we're also going to create a self.bet variable, but it's not that apparent to us right now that we're going to need it, so we're just going to stick with these two simple pay and win methods. So what we can do, for example, is we can take our player 1, and to it we can call pay, so they're going to bet, and let's have them bet 20, and then let's just print out our player 1 dot money, so just to see how much money we have left. And then let's say our player 1 wins 40. So they paid 20, then we see how much money they have, and then they win. And then let's just print out the player 1 money just to make sure that everything works here too. And let's just run this, and we see, well, this is our output from before, and we've also got this. This is kind of starting the new round. And then after we pay 20, we see that our player 1 has 80 money, and then after we win 40, we see that we have 120. So that seems to work pretty well too. If we cut this, and if we put this in front of our play, we also want to make sure that, and maybe we print the player 1 money afterwards too. So print player 1 money. We just want to make sure that if we play again, our money isn't going to change. So we're going to start a new round, but we're not going to kind of reset our money. And it shouldn't do that because in our play method here, we didn't actually touch any of the money, but let's just make sure, just in case. And we see here that first we have 80 then after we pay, and then we win, we get a 120. And we see our hand kind of here after we started the new game, and we see that we still have 120 money. So there are no units attached to this, so you can kind of choose what units you want to have, but we'll just keep it unitless right now. But yeah, so this seems to work quite nicely. We've got some kind of general methods set up right now that work pretty well, at least initially. When we make this game more complicated, we're probably going to need to revisit some of these methods and make them a bit broader so that they can kind of take care of more things, because otherwise our programs are just going to get too complex and we're going to need to remember a lot of things outside. But we want to make sure that our player does most of the stuff themselves, and when we actually play our game, we only need to call a couple of functions like hitting and maybe what happens to their bet, and maybe playing another game or something like that. So we want to keep it as simple as possible in our game, and we want to make sure the player handles a lot of the stuff themselves so that we don't have to do a lot of extra programming when we actually program our blackjack game. Let's continue with our blackjack game. Specifically, let's continue with our player, and let's implement a betting function. So right now we only have the pay and the win, but what we want to do is we want to be able to kind of change this a little bit around so that we can have a bet and a corresponding win, and that the player gets a certain amount of their money back plus extra if they win, and stuff like that. So we'll kind of see, for example, if the player bets 50 and they win, they should get back 100. And if they bet 50 and they get a blackjack, they should get back 125, because a blackjack gives you 150% of the money back. So that's what we're going to try to implement. So we can kind of see from last time, just to kind of recap quickly what we did. We have this create deck function that gives us a shuffled deck. We created our player that has a hand, a score, and money as properties. We've been able to print the player using this override function here, where we print the player's current hand and their score. We have this set score method, which we can call after every time a new card has been added to the player's hand, so that it recalculates the score, and it also takes care of the aces for us. The player can hit a card, so he can get new cards. The player can start playing a completely new game. And now what we're going to try to do is we're going to change this pay and win around a little bit, to make it a bet and win. So the first thing that we're going to need to do, or the first thing that we're going to want to do, to make our life a little bit easier, is we're just going to add another property to the player, and that's going to be their bet, so the amount of money that they bet. So we're going to go in here into the initializer, and we're going to add a self.bet, and we're just going to set this to 0, because when we create a player, we say they never have a bet yet. So they've never bet anything yet. They just kind of sat down, they haven't bet anything yet. The betting only starts later. So this is just kind of this extra attribute that we add to the player. It's going to be a self.bet, or it's going to be a bet, and that's part of the player, and what we're going to save in here is the amount of money that the player bet. So it's going to be in here for a little bit, and then we're either going to throw it away, so the player's not going to get it back, or we're going to double it or something, and the player is going to get all of their money back and more. So that's what this bet is going to do. It's going to be like a temporary placeholder for the money, and then we're going to decide later if they get it back or not. Yeah, so to make use of that, what we're also going to do is we're going to change this pay function a little bit, and we're going to actually rename it to be a bet. And so all we're doing is we just changed the function name right now. And what we want to do with this bet function is that we want our player to be able to bet a certain amount of money. And we just put the amount in here. So all that we're going to do is, well, we're going to take the amount away from our money. And what we're going to do is we're just going to transfer it to our bet. So we're going to take our self.bet and we're going to increment it by the amount. So all that we're doing is, if our money is, let's say we start off with money 100 and then we bet 20, what happens is our money goes from 100 to 80, and our bet goes from, our bet goes from 0 to 20. So that's what's going to happen. We're just going to kind of shift this money around a little bit. The player's going to have their self.money and their self.bet, and so they're going to have it both there, and it's just going to be shifted around a little bit. So that's all that we're going to do with the bet. So yeah, so we're just going to let the player be able to do this. And so the next thing that we need to do is we're going to define a win function. So we have this win here, and since the player is keeping track of how much they bet, we only need to know if they won or not. So instead of winning a certain amount, we can just kind of put in the result. And this is going to be a true or false, and it's going to tell us if they won or not. So what are we going to do? So our kind of in our results, we imagine the result to be true or false. And so if we get win with true, that means the player won. So what happens if results is equal to true, true, like this. So, in capital. So if the player won, what we're going to do is our self.money, we're going to add to it 2 times the bet amount, self.bet. So why 2 times? Well, it's just standard that if you win, then you kind of get double what you bet. So if I bet 50 and I win, then I get 100 back. So the 50 that I bet plus the extra 50. And since we kind of took away some money into the bet, so since we put, well, in this case, we put 20 into the bet, then if we win, we get our 20 back from the bet, and we get an extra 20 from winning the bet. So we kind of get 2 times because we took it away first, so we have to get twice this. And then we also have to change our bet back to 0. So self.bet is going to be equal to 0. So we're just going to reset our bet. So we won, we get some money, and our bet goes back to 0. And if the result isn't true, so else, our self.bet is also going to be equal to 0. So what happens if we win? If we win, well, we get twice the amount that we bet. So we get our bet back plus the same amount in winnings, and our bet goes to 0. Otherwise, we just lose our bet. So effectively, we lost money. So our money went here, for example, from 100 down to 80, and then our bet went from 0 to 20. And if we lose, then our bet's going to go down to 0. And so now the money is kind of gone. It's disappeared. We've lost it. So this is the simple kind of win function. We should take care of one more thing, and that is if we have a blackjack or not. So how are we going to take care of that? Well, we should probably check for the special situation of if we have a blackjack. So what we can do, for example, to check for that is if our so first of all, let's consider what do we need for a blackjack? Well, for a blackjack, we need 2 cards and we need a score of 21. So a blackjack is if we have 21 with 2 cards. Those are the kind of requirements. So the first thing that we need to check is if our self.score is equal to 21. So is our score equal to 21? Well, there's one more condition that we need. So just being equal to 21 doesn't give us a blackjack because we could have 777, for example. So if our self.score is equal to 21 and so now we need to find the length of our self.hand. So how many cards do we have in our hand? So we're going to look at the length of our self.hand. If this is equal to 2, so what are we doing here? We're checking first if our score is 21 and if we have 2 cards in our hand. So if we remember our self.hand, so the hand attribute of the player contains an array. And if the length of this array is 2, that means we have 2 cards in our hand. So if we have 2 cards and our score is 21, then we have a blackjack. So if that's the case, then what we can do is our self.money is we're going to add, and now instead of adding 2 times, we're actually going to get 2.5 times our self.bet. So we get a little extra for getting a blackjack. So that's why we need to take care of this blackjack example, because if we get a blackjack, we get a little bit of extra, so we get 2.5 times instead of just 2 times. Yeah, and else we're just going to get 2 times. And then no matter what happens, we set our bet back to 0. So what did we do here? Well, if the result is true, so if we won, then we're going to check, is our score 21, and do we have 2 cards in our hand? If yes, that means we have a blackjack. And that means we're going to get 2.5 times the bet that we put in. Otherwise, we're just going to get 2 times. So in either case, we won. We just want to see now how much we won. And after we added the money, we're going to reset our bet back to 0. And if we didn't win, well, we're just going to put our bet to 0. So yeah, so this is how we've dealt with the bet function. So we have, maybe one thing that's important to note too is that we have a bet method that belongs to the player. So we can call, so here inside the player, we can call the player.bet as a method. So if we put brackets around, and we can also call the attribute. So let's just see that in a second. And maybe let's take away this pay function because it doesn't really make any sense anymore because we don't have it anymore. But instead, let's go into player 1 and let's bet 20. So now we access the bet function because we put the parentheses around, and the amount that we put in here is the amount that goes in here. And so now the player has bet 20. And just to see that, let's print out the player money, and let's also print out the player1 dot bet, like this. So here we're printing the money attribute of the player, so how much money they have. We're printing the self.money, and here we're printing the self.bet. So here we access the bet method because we use the parentheses after the name here, but here we're accessing the bet attribute because we didn't put any parentheses behind. So we're going to need to change this too. So if we say, for example, win is true, like this, so this is what we win. So what we're going to see first is we're going to bet 20, then we're going to see our money and our bet, then we're going to win, and then we can see our money, and let's also look at our bet again just to make sure everything works. Yeah, let's just run this, and then let's kind of see that in action. So what do we do right now? Int object is not callable. Player1.bet self amount. Maybe we do have to change the name here. So what if we put in bet money? Let's see if that changes anything. Okay, so we actually did have a naming problem, and Python doesn't like it if we have the name of our variable and the name of our method the same. So we just saw we got an error, and that's because we can't, we kind of had a name clashing. We had the bet method here and the bet attribute here. So we had to change the name of our bet, and now it all works. So what are we getting? Well, we get our shuffle deck, we get our cards and our score, then we hit 2 more cards, hit 2 more aces from here, and we see our cards and our score again. Then we bet 20, and we see our money here, and our bet here, and now we win. And so we see our money here now, and well, we see our money here, and our bet's 0. And now we see here our player 1, and then we kind of play again, so we play a new round. This time we see our cards as an ace and a king, which gives us a score of 21, and we see our money. So what happens if we now just maybe bet and win one more time, just to make sure the BlackJack function wins too? So if we go into, if we say player1.bet, we have to call it, it's called bet money. So if we go into player 1 and we bet money, let's say we bet another 20, and then we're going to say player1.win, win, and the result's going to be true. So player 1 is going to win. And then let's just look at our player1.money and our player1.bet again. So we kind of bet and won in this round, and now we got new cards, and we bet and win again. And we just want to make sure that the BlackJack checking works, so that instead of getting 20, we should now get an extra 30. So yeah, let's see if that works. So yeah, it does work. We are now at 150. So we've actually got a floating point number here. And well, that's because we have this 2.5 here. So we're multiplying it by a floating point number. that's not really a problem. Python is very good at handling this stuff, so at handling integers and then floats, and it can just kind of change between depending on what you give it. So here it's not going to be a problem. It may be a problem in some other languages, but Python is really good at handling all this stuff. So it's great that we can do both floats and integers. So what we see here is instead of getting 20, so an extra 20, so being at 140, we actually got an extra 30. So we got the 2.5 amount. So if we had, we bet 20, which puts our money back, or put our money back down to 100. And then we get 2.5 times 20. So 20 times 2 is 40. And then another half of 20 is 10, so 40 plus 10, and that gives us 50. So we take 20 away from here as our bet, which gives us 100, and then we win 50 in total. We get 50 back in total, so 30 of that is the win, and 20 is our bet. So we get the 150 rather than the 140. So our blackjack check seems to win too. So that's really cool. Now, if you've ever played blackjack, you'll probably also notice that right now we are betting after we got our cards, and you don't really do that. Now, there are some things that we can do. So we can either design our game that the players always bet or pass, so they don't play this round before they get their cards, or we can put an extra check into the player and see if they already have cards, then we don't allow them to bet. So we can do either or. We'll probably implement the first method here. So later on, we're going to implement that we just kind of make the players bet before they can do anything else. So we always ask them for their bet, or if they don't bet, then they're not going to play. So that's just what we're going to do. We're not going to allow them to bet afterwards. But we can also do that in a different way, and we can just kind of allow the player manually to bet if we want to make the game a lot more dynamic. But and then we can kind of, in the bet function in here, we can just check if the length of our cards, if it's not 0, so we have cards already, then we can't bet anymore. But in our game, we're just going to have a strict kind of order, and it's going to be bet cards, and then do some actions with those cards, and then check the results. So do some action as in like hit, so take more cards, or pass, don't take any more cards. Yeah, so we'll get to that too. Now that we've created this player class and we have this create deck function, which creates a custom shuffle deck for us, we're going to use this, and we're actually going to start creating and playing our game. So I've kind of taken out all the testing that we've done before, and I've just left with the essentials. So we have our player class here that we've kind of spent a long time creating, and our create deck function that shuffles the deck. So let's just also take out this comment to just have everything relevant. Okay, and let's try to create a working game. So first off, let's just take our card deck and let's make it. So our card deck is going to be equal to, and then we call this create deck function that we've created. So that's going to give us our randomly shuffled card deck. So if we print out our card deck just one more time, just to make sure, and we run our code, we see here we have this nicely randomly shuffled card deck. If we run it again, we get a different shuffled card deck. So this is the create deck function that we're using that gives us back this randomly shuffled deck, and we're going to save that in the card deck. Now, one more thing that I'm going to show you that's very cool, and that's going to help us make this a lot easier, is going to be a way to simulate drawing cards. So what we're going to do is, first let's just print out the card deck like this, and what we're going to do, and we'll print it out again after we're done, in between we're going to use a new function on the list, or we're going to use a method that's inherent to the list that's going to give us a card. So what we're going to do is, and we're going to print out the result, we're going to go into card deck, and what we're going to call is something called a pop function. Now what that does, and you'll see that in a second too, is it's going to take away this last number here. So actually, let's just run it and then we can see it in action. So what it does is it takes the last number here and it pops it, in essence, that it takes this last number, it puts it out, and we see it actually reduces the size of the list by 1. So what it does is it accesses this last number, it takes it out, and it reduces the size of the list by 1. So in essence, this is kind of like drawing a card. So if we can also pop again, for example, so we can go into card deck, and here we can go pop, and then it's a method, so we have to put the parentheses behind to call it. And we see here we have ace and 6 as the last two cards. First we kind of pop out the ace, then we pop out the 6, and now we're left with the king here. So you can see the order is not changing, it's just we're kind of taking out the last element by element. So every time we pop, we take out the last element. So we're going to use this to create, to kind of resemble giving out cards. So what we're going to do is let's just create two little lists first. So this is going to be our first hand. And what the first hand is just going to be, it's just going to be the first, or so we'll assume this is the top of the deck. So it's going to be the top two cards of the deck. So we're going to card.deck.pop. So this is going to be our first element, which is the top of the deck. In this case, it would have been the ace. And the second element is just going to be the number or the face value after that. So we're going to card.deck.pop again. So what our first hand is just the top two cards of the deck. So we've taken away this card here and this card. And our second hand is going to be, and we're going to do the same thing here, card deck.pop. So this is going to be the third card. So we've popped the list here, which got rid of the ace. We popped it again, which got rid of the 6. Now we're popping it again, so that gives us the king. And one more time, card deck.pop, like this, and that gives us the queen. So our first hand is an ace and a 6, and our second hand is a king and a queen, directly in that order. And we can use this to create two types of player classes. So we're going to create a player 1, and we're going to create a house. So our player 1 is going to be equal to player, and let's just say our player 1 gets cards first. So our player 1 is going to be equal to player, and their hand is the first hand. So that's what we put in here as the initializer. Our hand is the first hand. We don't put in any money, and since it has a default value, it's fine. We can just leave it like that. And our house is going to also be a player class, and their hand is going to be the second hand. And then maybe let's just print out player 1, and let's print out the house, and maybe in the very beginning we can also print out our card deck just to make sure everything worked correctly. And so let's run this code. And so we see here we have the 10 and the 2, and that's in the player 1 because they have the first hand, so that's the first two cards, which gives us a score of 12, so that works nice. And then the house has the 6 and the king, so the third and the fourth card, which we see here in order, and their score is 16, so that also works nicely. Perfect, cool. Okay, so now we kind of know how to create hands and how to at least initiate the game. So now we actually need to start playing. So what do we do? Let's just take out all these print statements first, and now we're going to ask for user input. So what we're going to do is we're going to have an action variable, and this action variable is going to be represent user input, and we're just going to kind of continue to ask the user for input if they want to take a card or not. So if they want to hit another card or if they don't want to hit another card. And we're going to just kind of print their current standing out to them every time too. So we're going to print their hand to them first, and then we're going to ask them, do you want to take a card or not? And then if they take a card, we'll print out their hand to them again. So kind of like that. So the action is going to be, and now we're going to ask input, and we're just going to ask the prompt the user kind of, do you want another card? Like this, and then maybe we just put in brackets behind here, yes slash, where do we go here? Yes slash no, no. So we're going to ask for either a Y or an N to resemble a yes or a no, because that's what we're going to be checking for. And then we have a colon here and a space just for some formatting. And then what we're going to do is we're going to check if our action is equal to yes. So what we're asking the user to do is we're asking them for input, do you want another card? Yes or no. If they do, so we're only going to check for Y or N, that's going to be the yes or no. If they do, we're going to give them another card. So what we're going to do is if they put in a Y, like this, so we get this all out in a string, so we don't need to really check for much. We can just check if the value they put in was a Y. If it was, then what we're going to do is we're going to go player 1, and they're going to hit. And what are they going to hit? Well, they're going to hit, or they're going to take the next card in the card deck. So they're going to take the top card, so they're going to go into card deck dot pop. So this is just going to give them the top card, and we don't need to save this in a variable. This is just kind of, as we see here, that just kind of gives you the output directly. So we don't need to save this in a variable or anything. We can just directly put it in here as input. So what would happen here, for example, if we popped an A, then the A would get put in directly here as a string, and then it would get put in here as the card, and into the hand we would append this card, and then our score would be set accordingly and such. So yeah, that's kind of what's going to happen here. We don't need to save this in a variable or anything. We can just kind of directly put it in. And then let's just print the hand, or let's just print player 1 to the player again. So let's run this and let's see what we get. Do we want to hit another card? Yes, we do. And so this is, oh, well, we didn't print the hand before, so we should probably tell them what they have before we ask if they want another card. And just for fun, let's also just print out our house before and after, just to kind of see. So we can also print out our house afterwards here, regardless of if they want another card or not. And just to also follow along, let's also print out the card deck, just so that we can kind of see where all the cards are going and stuff. So this is going to be the card deck after the top 4 cards have been removed already, because that's what we're doing up here. So this is going to be the remaining cards. So let's run this. So we see this is kind of the remaining card deck. The house currently has a king and an 8, although we wouldn't usually be able to see this, so we'll also need to take care of that. And the player has a 4 and a jack. And so we're asking, do you want another card? Let's just say yes. And now we see, well, we have a 4, a jack, and a 4. That's our player, and our house has a king and an 8, and they both have a score of 18. Well, maybe we would have wanted another card. So we kind of have to take care of that. Maybe what we can do is we can put in a loop. So we just kind of loop and loop until the player says, no, we don't want another card. So what are we going to do? Well, one of the ways that we can do it is we can use a while loop, and let's just make it infinite again. So we're going to loop and loop until the player says no. So we're going to have an infinite loop here. And so we use this while true. So if you don't remember what the while true means, it's while and then it checks in here while true is equal to true. And since true is always equal to true, it's just going to loop infinitely until we cancel it. So what we're doing here is we're checking if, so the action is the user input, if it's equal to Y, so yes, then the player gets another card and we print what they have. Else, so if it's not equal to Y, we're just going to break out of the loop. So we're going to assume that if they don't put in Y, they don't want another card, and that's it. So we break out of the loop then. So yeah, we can do that. Maybe let's also just print the house in comparison, just so that we kind of know. And then we don't have to print it out here again, just so that we also know where the house is at, so that we can kind of continuously check and we don't have to scroll up or anything. So we see this is our remaining deck of 48 cards now, because we took away the top 4 and we distributed to the player and the house here and the player. And now we asked, do we want another card? Well, sure. And now we see that our player has 25, so that's not really good for us. That is over 21, so damn. But yeah, the house is 19. Now we still have the option of getting even more cards, so we need to take care of this too. So you see we can get even more cards now, and if we put in anything else, so like if we put in the N, it breaks out. So yeah, so this is the first kind of test. So maybe what we can do is, instead of having this be an infinite loop, we can say while the player 1's score is less than 21. So if they have 21, we're not going to let them do a mistake and have them take another card. So we're just going to check while the player 1's score is less than 21. We're going to continuously give them the option to draw more cards. And the way that we get out of this loop is either the player goes over 21 or they don't want any other cards. So let's see that in action. So right now, so we print the house first, so that's what we see. The house has a jack and a 10. We have a jack and a queen. Let's just take another card just to kind of see our example. So yeah, we take another card. We see we get 24. We don't have the option of taking another card again. So that seems to be working nicely. Let's just run that again, because that was, well, the house got a blackjack, so not much we can do here. We can take a jack though, and we see here now we've drawn an ace, and it also shows us. So the ace is counted as a 1 now, because giving it an 11 would have made us go over. Let's take another card. Now we're at 22. Great. So we've lost again. We're not really doing well, even though we can see the house's cards. But oh well, that's the way it is. Yeah, but it seems to be working. Cool. So we've taken care of this now. Maybe what we want to do is we want to create a little function that lets us print the house, but it kind of hides the first card. Now, of course, we could have made a completely different class from the house, so obviously the house wouldn't need a bet, it wouldn't need a win really, and we could create a kind of different subclass, or we could have made the house first and then made the player be a subclass of the house and given it this bet and this win function, or this bet and this win method. We could have done that. We didn't. We wanted to keep it simple. So what we're going to do real quick is we're just going to create a little function, and that's going to print the house and the score, but it's going to hide the first card. So what we're going to do is we're going to define a function called print house. Inside we're going to put the house, and then what we're going to do is we're just going to access the house's attributes directly. So what we're going to do is we're going to loop through it. So for card in, and we actually want to access the cards, the house's cards index by index now. And what we're going to try to do is we're going to hide the first number, and we're going to kind of print everything else out. So for card in house.hand, so we're going to access the hand of the house. So this is this hand variable that we're accessing, but we want to access the length of this, since we want to get indices and we want to do range. So what we're doing is our card is going to take on, and then we want the colon here, our card is going to take on the values 0 going up to, but not including the length of that hand. So if we have 2 cards in our hand, for example, our card's going to take on the values 0 and 1. And so if we have 5 cards, the card's going to take on the values 0 through 4, for example. And so we can use that to nicely access the individual cards in the house's hand index by index. So what we're going to do is, if our card is equal to 0, so if it's the first card, what we're going to do is we're going to print, and what we're going to print is just an X so that we can't see anything. And what we're also going to do is we're going to change our end separator. So our end is going to be equal, and we'll just put a space here. So if you remember, this is the formatting. So instead of printing a new line, we want to kind of continue printing on the same line. And since we're always going to have at least 2 cards, we're just going to kind of continue printing these spaces afterwards. Then the next thing that we're going to check is if we're going to check if our card is the final value in this range. And that's just for formatting. So what we're going to do, we're going to check if card is equal to, now we want the length of the house's hand. So that's what we're looking at. But since the range goes up to but not including, we actually want to see if the card is equal to the length of the house's hand minus 1. So if, for example, the house's hand is 5, house.hand is 5. So if the house has 5 cards, like this, what we want to show, or our range is going to, that was a little bit too far back, our range is going to give us the values 0, 1, 2, 3, and 4. So our last value is actually going to be the length of the house hand minus 1. So if our card has that value, all we're going to do is we're just going to print, we're going to print the house's hand, and we're going to print the corresponding card corresponding to this index. So we're just going to print the last card. But we're not going to add this extra end here so that we get a new line afterwards. So this should be an elif. So either we have the first card or we have the last card, and if we don't have the first or the last, else what we're going to do is we're just going to print the house's hand, and we're going to print the card corresponding to the index of card. So our card is taking on the values for example, for 5 cards, our card's taking on the value 0, 1, 2, 3, and 4, and these are the indices. So if we have, for example, 1, and we access the house hand with index 1, that's going to give us the element at index 1. So that's going to give us the corresponding card here. And here again, we also want to add the end separator. So end is going to be equal to, and then just a space, just like that, so that we get this nice formatting, so that we print out an X first, and then we print spaces and spaces until we reach the final card, after which we print out a new line. So that we're just going to make sure that everything is on the new line, on the same line, and then afterwards we go to a new line. So that's just what we're kind of doing here in this print house function. So what we can do, for example, is instead of printing the house, we can call print house on the house. And so that's actually going to give us all this printing already. And here we can again replace print with print house. So let's see that in action now. So now we see our house has something and a queen. And we also didn't print the score, so we don't know what this is. And we have a jack and a 9. And so we have 19. And do we want to draw another card? Well, probably not. So we've got a pretty good hand. Well, we don't know what happened, so maybe afterwards we should actually print the full hand of the house. So here we actually want all the information, because now the house kind of turns over what they have. So the house has something and a 5. We've got a 13. Maybe it'd be smart to take another card. Yeah. Well, we've got 20 now, so no, let's not take another card. And now we see the house has 10. And now obviously they would also be taking new cards and stuff, but we'll get to that in the next video. So the next video is going to focus on the house kind of continuing to take cards, and then we're going to compare the scores, and we're going to see if you win or if you don't win. And we're also going to include betting. Yeah, but so now we've seen kind of the player side taking the input. We've seen this cardDeck.pop function, which lets us take off the last value in the list, which is extremely useful. So this is a way that we can kind of simulate picking out cards from a deck, and since we're removing them immediately too. And we've also created this nice little function that lets us print out the house's hand without revealing the first card, which is a bit more like the actual game. Like I said, what we could have done, for example, is we could have made a house class first, and then we could have made the player a subclass of the house and just given it the extra functions of bet, money, and win. But that would have been a little bit more complicated, and it would have not been that nice to follow. It would have just been nicer. It's just kind of nice that we have this one full class that provides us with the disadvantage that if we print the house, for example, we print everything like we have here. So that's why we had to kind of create this little print house function that kind of lets us go around that and print the values of the house with this hidden card at first, so that we don't really fully know what the house has. Let's continue building out our blackjack game. So what we have right now is we can create different players, we can give them cards like we've done here. And we have this little loop that checks while the player has less than 21 cards. And while they do so, they keep getting asked for new cards. And if they take a new card, we give them a new card from the shuffled deck by using this .pop function, which removes the first card from the top of the deck. And we continue that until the player says they don't want any more cards or until they've gone over 21. And then we just kind of print out the house. So that's what we have right now. The next thing that we're going to want to implement is, well, first we need to check if the player has a blackjack, because that is very advantageous for them. And unless the house has a blackjack, they're going to get a big win. We're also going to need to continue to kind of put this into a bit more of a playable loop, so that you can't just play one round, but that you can kind of play over and over again. We also need to put in the ability to make bets beforehand. We're also going to need to automate the house's drawing of cards. Yeah, so that's what we're going to try to work on now. And so we'll start with the first thing that I mentioned, which is going to be defining a has blackjack method. That's going to be part of this player class, this one here. And what it's going to do is it's just going to allow us to check if the player or the house has a blackjack, so that we don't really need to code that out, and we can just make it part of this player class here that we have. Yeah, and so that just lets us check if they have a blackjack or not, and we can make some quick decisions based off of that. So let's start off, and we're going to call this method. So we're going to define the method using the def keyword, and we'll call it has blackjack, like this. Inside, we're going to need to put in our self, and that's all we're going to need to do. We don't need to put in any other parameters. We're going to use all of the internal parameters. So what are we going to do? Well, if it's a blackjack, just like here, so we've already kind of did a blackjack check. If the score is equal to 21 and the player has 2 cards in their hand, that means they have a blackjack. So if the self.score is equal to 21, so if your score is 21, or if the player's score is 21, and the length of the self.hand, so the length of their hand, so how many cards they have in their hand. So remember, the hand is a list, and each card is going to be one element in this list. So the length of this hand list tells us how many cards we have. So the length of our hand, if that is equal to 2, so if we have 2 cards in our hand and our score is 21, that means we have a blackjack. So if that's the case, we're going to return true. Oh, and we need to capitalize the true, so like this. else we're going to return false. So we're just making a little check for blackjack here. Do we have a score of 21? And do we have 2 cards in our hand? If yes, we're going to return true. Otherwise, we're going to return false. Just like this. Okay. So we can even implement that before this while loop here. And we can first check if, and then if player 1 dot has blackjack. So before we even start asking the player if they want cards, if they have a blackjack, then we don't even need to ask them for cards. So if player 1 has blackjack, so technically we can make this equals equals true, like this. But we can even take this out and we can just say if player 1 has blackjack. And so this gives us a true value. And if true is always going to be executed. So if we have an if true, that's always going to be executed. So we don't even need to check if it's equal to true. It's kind of similar to the infinite loops that we use. So for example, like this, while true, we can technically put in while true equals true, but we don't have to. And it's the same thing with these if statements. We can put in while some condition equals true, but we can also just put in if true, and that would work too. So this has blackjack is either going to return true or false. And if it's true, this if statement is going to be executed. If not, well, we're not going to execute it then. So if our player 1 has blackjack, and if our house, so now we need to check, does the house have a blackjack or not? If house dot has blackjack, well, then we don't really do anything. So what happens? Well, we return all the money to the player. So it's kind of a draw. So we should probably also consider that in one of our functions up here. So right now we only have the option of a win and a bet, but we should also implement a draw just in case. So we're going to create another method up here, and that's going to be a draw. So we can either win or draw. So we can draw if our cards are equal. So if we both have 17 or if we both have a blackjack, for example. So we're going to define a draw to be self. So we're just taking in the self parameter here. And so if it's a draw, then our self.money, we're just going to get our bet back. So our self.money is going to be plus equal to the self.bet. And the self.bet is going to be equal to 0. So we just kind of transfer our bet back to our money. So nothing happens. We get the original money that we bet back, but we don't get anything else. So we're going to use this, and we're going to say if the player 1 has a blackjack, and if the house has blackjack, then we do player 1 dot draw. So it's a draw, and the player just kind of gets their money back that they bet. Else, we say player 1 dot win, and we have to put in the result, and so the result is going to be true. So if the player has a blackjack and the house has a blackjack, it's a draw, which gives the player back their money, gives the player back their original bet. Otherwise, it's a win for the player. So if we put in true here, we see that we already accounted for the blackjack case here. So this is all being done in here, and we don't really have to consider the different winnings based on a blackjack or not. So that's really nice that we can do that, and we can just say, so if the house does not have a blackjack, so the else statement, then the player 1 is going to win. Yeah. So this is our first else statement, and now what we can do actually is we can take this whole loop and everything, and we can put that in an else statement. So else, and we're going to take all of this, and we're just going to comment it over. So what we're doing now is first we're checking if the player has a blackjack, and if they do, then we check if the house has a blackjack, and if they both have a blackjack, the player 1 gets their bet back. Otherwise, the player 1 wins. And if the player 1 does not have a blackjack, we're going to start with this looping procedure here. So if the player 1 score, or while the player 1 score is under 21, we're going to continuously ask them if they want another card, like this. And yeah, and then we already built this out, so we kind of have this whole situation panned out here, where the player draws their card, so we don't need to worry about this much more. The next thing that we can do is we can now make the house draw their cards. So and now we need to define a condition. How long does the house draw cards for? So let's say the house draws until they have a score of at least 16. So while the house's score, while the house dot score is less than 16, the house is going to draw a card. So how are we going to do that? Well, similar to how the player 1 drew a card, but we don't ask for input or anything, we're just going to do house dot hit, and we're going to take the top deck off our card deck, so card deck dot pop, and then open and close parentheses, because our pop, we don't actually see it. Our pop is a method that's part of this list here, so it's not an attribute, it's a method that we have to call, and so that's why we have to put these parentheses here. So what we're doing here is first we check if the player has a blackjack. If they do, then we check if the house has a blackjack. If the house also has a blackjack, then the player just gets their bet back and doesn't win anything. Otherwise, the player 1 wins, and we accounted for the blackjack situation already in here. So yeah, that kind of takes care of the blackjack situation. Otherwise, we continue to ask the player while they have less than 21 if they want another card. If they do, they get another card, and if they don't want another card, or if they go over or equal to 21, then we're also not going to give them any more cards. So this is going to happen until they either have a score of 21 or above, or they say they don't want another card. And after that happens, we kind of finish this loop, and then we go into this loop here, and then we check, well, while the house has a score that's less than 16, the house is going to draw some cards. Cool. So let's just run this and see where we're at right now, and then we can continue. So if we run this, first we see our deck here, and this is after 4 cards have been drawn. So what is the next thing we see? We see the print house. So we call the print house function that we defined on the house. So that's what we defined up here. Maybe we can just make an extra indent or extra new line here. And what this gives us is the house's cards, but one of them is blocked out, so their first one's blocked out. And then let's see, what's the next thing we see? The next thing we see is the player 1. So let's see, what do we have right here? We see our player 1, and we check, do we have a blackjack? Well, we don't, so we go into the else statement, and now while our score is less than 21, so we should be asked for a card. So what we forgot to do is we don't have the open and close parentheses here, which is kind of what we need because this is a method and this is not an attribute. So we need to have the open and close parentheses here, and then it's going to check for house blackjack. So similar like for the pop here, we need the open and close parentheses. We also need it here for the house blackjack because it's a method. It's not an attribute, like bet is an attribute. House blackjack is a method. So we need these open and close parentheses here to be able to call it, or else we don't really know what we're talking about. So if we run it again, now we see, well, we get a kind of new shuffled card deck. This is what the house has right now. Oh, it looks very similar to above. What we have right now is a king and a 10. Do we want to draw another card? Probably not, so we're going to say no. And so the house has a score of 18. So we win, but we didn't account for that yet. So maybe we should account for that. And we didn't see it now, but maybe we also just want to print what the house has every time they kind of draw. So we're going to print out the house here too, and so we get to see what they have every time they draw. So that would be pretty nice too. So that's just kind of lets us see the house draw card by card. Okay, Actually, we can put this on top because we're printing the house out at the very end too. So we can just print out the house here. It's not going to make a difference. The only difference that we're going to see here is either we see the house's hand after they drew a card or before, but we'll continue to see it anyway. And if they get over or equal to 16, then we're going to see it down here anyway. So it doesn't really make much of a difference. So we can just run it one more time. Hopefully we get to see the house actually draw some cards this time. So this time, do we want to draw another card? Yes, we do. We're at 19 now. So let's not draw another card. And here we see the house drew another card. So this is the first thing that the house started off with. So their crossed off number was a 10. So their original score was 12, and now we see them draw another card, and now they have 20. And now also the house stops drawing cards. And so what do we need to do here? Well, we need to check who has won. So that's the next thing that we're going to need to do. We need to check if we won, or if the house won, or if it's a draw. So how are we going to do that? Well, let's just make it really simple, and let's just check the 3 different conditions. So the first thing that we're going to do is we're going to check if our score is bigger than the house's score. So if player 1 dot score is greater than house dot score, then we're going to do the following. So we have to make sure that this if statement is after this while loop. Otherwise, we may be in the situation that we win while the house is still drawing cards, and we win every time the house draws a card until maybe they actually get higher than we do. So if the player 1's score is greater than the house's score, what are we going to do? Well, the player 1 is going to win true. So if our player 1 score is greater than the house score, we're going to win, except if we go over 21. So maybe we should even account for that first. First we check, did we lose? Did we go over 21? And if we didn't, then we can check all these situations. So first, maybe let's check if player 1 dot score, if we're greater than 21, well, then we need to check for 2 situations again. Either the house also has greater than 21, in which case nothing happens, it's a draw, or the house has less than or equal to 21, in which case we lose. So if our score is greater than 21, and here, so now the next thing we're going to do is we're going to check if the house's score is bigger than 21. So if the house's score is bigger than 21, then we're going to draw. So player 1 dot draw. So what are we checking here? We're checking first if our score is bigger than 21. If it is, then we check, does the house also have over 21? So did we both kind of bust? Did we go over 21? If we did, then it's a draw. Else, now if we go over 21 and the house didn't go over 21, then player 1 dot win is false. So we lost. So if we go over, we best case scenario draw. Otherwise, tough luck for us. Then we lose. So this is our first if statement. So we checked if we're over 21. And now we're going to do an else if rather than an if. So if we're not over 21, we're going to continue on with this, since we don't want to check for this in case we go over 21. So what are we going to do now? So if our player 1 dot score is bigger than our house dot score, then we win. So now we don't need to check for this bigger than 21 situation anymore. If our player score is not bigger than 21, but our score is bigger than the house's, that means we win. So we didn't lose because we didn't go over 21, and if our score is bigger than the house, then we win. So not much more to do here. So elif, now we need to check, maybe is our score equal to the house's score? So we're just going to go in order. Else if player 1 dot score is equal to the house's score, house dot score like this, then we're going to have a draw. So, and we also need this indented like this. So this all needs to be in the same line here, in the same if statement. So if our scores are equal, then we're going to say player 1 dot draw like this. The last thing that we're going to need to check is, so, again, it auto indents, which is not nice here. So first we check, did we go over 21? If we didn't, then we check, did we win against the house? And if we didn't, then we check, do we have the same score as the house? And if all of this is false, that must mean our score is less than the house. So else, well, what happens? So if our score is less than the house, there is still one way that we can win, and that's if the house went over 21. So else, now let's check our last hope and see maybe the house went over 21. So else if the house.score, oh, and we need an if statement here. If the house.score is greater than 21, then we also win. So why do we win? So player 1.win is true. Why do we win? So if the house goes over 21, that means they lost. And we never really truly checked for this. We only always checked our score. And so there's still this one situation left where our score is lower than the house's score, but it could be that we have a 21, for example, and the house has a 22. And so if the house goes over 21, that means we still win. And we could have a 2, for example, and the house has a 22, and we'd still win because the house went over 21. So if the house's score is greater than 21, then we win. And otherwise, unfortunately, we lose because there's no other situation left. So our win is false, not true. False like this. So why can it be equal here? It's because we already checked for if they're equal before. So if our score isn't bigger than the house, and if our score is not equal to the house, then our last hope is that the house went over 21. If they did, great, we win. Otherwise, we lost, so our win is false. So this should kind of account for all situations. And maybe at the very end, let's just also print out our money. So let's go in here and let's print out player1 dot money. So yeah, let's see that. And let's run our code. And what do we have here? So someone got a 21. Looks like we got a 21. And our money is still 100. Why is that? That's because we didn't bet anything. So everything seems to work. We got a 21. This was executed. We skipped over all of this. The house didn't draw any cards. Great, so that all worked. Unfortunately for us, we didn't bet any money, so our money didn't change. Yikes. So maybe let's just implement this bet in the very beginning here. So before we even see anything, we're gonna have the bet, and now we're gonna ask the user to input their bet. So bet is going to be equal to, and now we're gonna ask the user to input their bet. Input, and we're gonna prompt them with, please enter your bet, like this. And well, maybe we put a colon here and a space to have some extra formatting. So, and let's put this on a new line just so that we can see it better. What we see here is we have an input, and we ask the user to please enter their bet. And we save their bet in a variable called bet. One more thing we need to do is we need to turn this into an integer, because otherwise we get it as a string. So like a word pretty much in quotation marks. We can't do a lot with that because that's not a number, that's a word. So we need to turn this into an integer. Yeah, so they're gonna need to enter their bet. And then we can kind of continue and do everything. So let's do that. Let's run it again one more time. And now we're being asked to bet some money, so let's bet 20. And well, we got an ace and a queen, so we got a blackjack. That's great. Oh dear, we forgot to actually place our bet. So we asked for the bet, but we didn't place our bet. So we're having a really bad luck right now. So we need to go into our player, and we actually need to place the bet using bet money. So we need to go into player 1, and then we need to go here into bet money, and we're going to put in the amount, which is going to be the bet. So this is what we saved in this variable, and that's what we're putting in here. So on player 1, we're going to bet money, and the amount that we're going to bet is the amount that the player put in before. So let's run this one more time. Please enter your bet. We're going to bet 20. Well, obviously this time we didn't get blackjack even though we got it the last 2 times. That's really tough luck for us. Anyway, we've got a score of 7 now. Let's draw some more cards. Yes, we want another card. Now we're at 17. Let's leave that. And the computer got 18. So the computer won this time against us. Let's play one more time. So let's enter our bet again. Well, double or nothing, so we're going to go in for 40 right now. We've got 18. That's pretty good. So let's stay with 18. Looks like the computer got 17. So we actually won that round. Good. Great for us. So nice. Yeah. So we've kind of have like this working blackjack game now. We have the player that's asking. So we're asking the player for a bet. Then we're checking if they have a blackjack. If they don't, we continuously ask them if they want cards. If they don't, then it's the house's turn to draw. And then we check all the situations like this. And then we kind of print out the results. Cool. So we're almost done. Maybe one more thing that we can do is we can put all of this into a loop. And we can take care of shuffling. And we can also use the play function. Or the play method rather, that we implemented for the player. So that's just 2 more things that we're going to do now to make it really complete. But what we kind of see now is that we can play 1 round, and sure, we can start over every round, but the point of blackjack is also that some cards kind of, the deck gets smaller, so some cards kind of go out. So we don't want to start with a full deck every time. We want the deck to kind of get smaller and smaller until it's too small, and then it gets reshuffled. So that's the last thing that we're going to want to implement. So what are we going to do? We're just going to make an infinite loop. We're going to say while true. So this is just going to go on forever and ever, and that's okay. And now what we need to do is we need to indent all of this. So all of this is going to be inside of our loop. So we're just going to indent everything. So all we're doing right now is we're just kind of repeating this over and over and over again. And the first thing that we need to do before we even ask for the bet is we should probably check if the deck needs shuffling. So the first thing that we do before anything is let's just check, does our deck have enough cards? So and now what is the condition for having enough cards? Well, the condition for having enough cards should be that, well, let's say we have no less than 20 cards. So if our card deck, now since our card deck is a list like this, to check how many cards we have, we can look at the length of the card deck, or the len of the card deck, so the length. So the length gives us how many elements we have inside, and since each element is a card, that's also going to give us how many cards we have inside. So if the length of our card deck, so if the number of cards in our card deck is less than 20, what we're going to do is we're just going to completely reshuffle. So our card deck is going to be equal to create deck function like this. So what do? Well, we kind of don't really shuffle the deck back together. Kind of what we do is we just throw away the rest of those cards and we just get a completely new shuffle deck. So we don't really, take these remaining cards, we don't shuffle them. We don't do the typical blackjack thing that's kind of like a simple shuffle, so you just shuffle it a little bit, and sometimes cards kind of stick together and they're in the same order because it's not really a complete shuffle. We're not following that principle right now. We're just saying, well, if we have less than 20 cards, the next time we start the game, we just throw away the deck that we have right now, and we get a completely new shuffled deck. So that's kind of what we're doing here. But this also gives us back 52 cards in total. Yeah. And then we're just going to need to define the first hand and the second hand, just like we did up here. So what are we going to do? Well, let's just take our first hand and let's have that equal to, and then we're going to take the first card off the deck. So we're going to go into card deck dot pop. So we're going to take the top card off, and that's going to be the first card in our first hand, and the second card is going to just be, we're just going to pop another card off of our card deck. So what are we doing? We've created a deck with 52 cards again, and now we're just taking off the top cards one by one, and we're making those be a hand. So we're also not distributing it card by card, so not every player gets one card and then we go around again. We just say the first player gets the first two cards, and then the second player gets the second two cards, and so we're kind of going in order like that. So our first hand is going to be the first two cards of the deck. Our second hand is going to be equal to, and then we just pop another card from the card deck. So again, the pop function is just taking off the last card here, and then we just pop another one off the card deck like this. So what do we do here? We have our deck, and we're just taking the first and the second card off, and we're making that the first hand. Then we're taking the third and the fourth card off, or if this isn't our first round playing, it could be that we're taking, like, say, the 12th and the 13th card off, and then the 14th and the 15th, or something like that. So, but we're just taking kind of two cards off the deck. We're going to give that to a player. We're not doing it yet, but we're going to give it to a player. And then we're taking off the next two cards, and we're going to give that to a player. So what we're going to do is we're going to give these cards to a player. So our player 1 is going to play with the first hand, and our house is going to play with the second hand. Second hand, like this. So we're just using the play method that we created for the player, which is up here, and our input is the new hand, and it just gives the hand, so the current hand of the player gets set to this new hand, and we recalculate the score. So that's what we're doing here. And then we can ask for the bet and do everything. Yeah, so that kind of takes care of that. That takes care of reshuffling the deck if we have less than 20 cards. And we can also continuously play and just kind of get dealt out new cards. Maybe one thing that we should do before we start this is we can just make our card deck be equal to create deck again. Just because we created a deck here, then we're putting the top two cards into the first hand and the third and the fourth card into the second hand. We're giving the first hand to the player, so we're initiating the player with the first hand. We're initiating the house with the second hand. And then we're actually going to redistribute the hands. So yeah, I mean, there's a different way to do that, but since we already have a program, we don't really need to change it. All we have to do is just kind of recreate our deck so that we get back to 52 cards. And then when we redistribute the hands and everything will be reset anyway. And then after that, we don't really have to worry about anything anymore, because if we ever have less than 20 cards, it's going to be reshuffled. Otherwise, everything's just going to be overwritten. So yeah, this should all work nicely. And at the end of every round, we kind of print out our player 1's money, and we print out what the house had. So let's see all of this in action. Please enter your bet. Let's start with 20. Maybe we should also stop printing this card deck, or else we can kind of cheat. Do we want another card with 10? Yes, we do. With 12, well, if I assume I didn't see this 10 here, 12 would probably be a good time to take another card, yes. We went over 21, we got 22. We see that the house has 10. Now we're losing the money, so we go down to 80. And the house, well, actually the house continued to draw cards, so maybe that's also one more thing that we should take care of. So before the house actually draws cards, we should check if we went over 21. So maybe before the house even draws cards, we should check if our player 1.score, if it's greater than 21, then the house doesn't even need to draw, because we kind of already busted. Well, actually, no. We can let the house draw. We'll make it fair. We won't make the game too hard for us. So the house is gonna draw anyway. So we won't change that. That's gonna be okay. So now actually we can play again. We can put in another 20. This time we've got a 10 and a jack. So we got 20. We don't want to draw. Well, what happened? So We got 20. So they also had 20. So our money didn't change. We still have 80 from before. That's pretty good. So let's play again. Now we've got 14. Since we've got this ace, so they can kind of get transformed. So maybe we can take another card. So we've got 21. That's great. The house has 18. So we're back to 100. Great. So this all works nicely. If you want, you can kind of create an input. If the player puts in they don't want to play anymore or something, like you can break out of this loop. That would just be an extra if statement. You can also take away printing this card deck here so that we don't actually see the deck the whole time. Like this. Yeah, and then maybe let's just kind of completely run it one more time until we reshuffle our deck. So actually let's continue to print our card deck just for a little bit, just so that long enough so that we can see how our card deck's going to go down, and then we should see it getting reshuffled. So let's just continuously draw cards, and we're just going to bet one the whole time, and all we're waiting for is our card deck to go down like this. So we're just going to bet small amounts, and we're just kind of watching our card deck go down like this. So it's going down and down and down. Do we want another card? Yeah. So, wow, we're actually winning sometimes. That's interesting. Do we want another card? Yes. Yeah, sure. We're at 19. Oh, I might say no this time. We lost anyway. And here we see. So here, this is our card deck before, and so we can kind of see it. It's kind of going down. It's always the same one. So we see this 9, 3, 9, 8. This is all that we have here. So these cards were all drawn last round or distributed. And now we reached under 20 cards at some point. And so now we have a completely new and reshuffled deck. So that all works nicely too. So yeah, this kind of completes our blackjack game. You can expand on it a little bit, of course, if you like. You can kind of add more features, more statements. You can add more players even if you like. And to take care of the rounds, you can use arrays. So you can put all the players into an array, for example, and you can use that to take care of having each player individually bet and stuff. So you can kind of use a for in loop to go through the arrays of the players one by one, and for each element you can kind of execute this. So you would just put an extra for in loop on top of this while inside this else statement, for example. And so there you can kind of create a list of players, and you can just loop through each of the players and ask them if they want more cards or not. So you can add each of those extra features. But yeah, so this is a working blackjack game that we created. So that's really cool. We kind of combined all the skills that we've gathered so far. We used a little bit of everything, and we've created our first long project. So this is the first kind of long project that we did, but it's a really cool working game. That's kind of fun to play. Maybe one more thing that you'd like to do when you actually play this is take out this card deck, just so that you don't see all the cards that are coming, or else that's kind of cheating. Yeah, but otherwise, have fun with it.